Hello coders, welcome to my video. So today we are going to study about the earner variable. So this is very important while we are debugging uh, or we need a log in the production grade server to identify the exact root cause of the APIs or the system call that got failed during the execution. Okay, so this Errno variable is mainly set by the kernel on failure of the system call and some library functions. So why it is being used? So this Errno variable will identify the exact error that happens in the kernel layer. So if we have to get the flow of this earner variable where it is being set. So for example, I have used a user code. I have a user code here, okay, some application, and it will have some system calls that will call the glibc wrappers, okay, and it will obviously call system calls, and system call will interact with kernel, okay, and kernel will set error, and whatever error it returns, for example, -1, and it will set the no variable. What do you mean by that? So this return -1 is to this glibc system calls. So whatever system call we have, this kernel will return -1 to it. So that glibc system call will identify, okay, so there is some error in the execution of that system call, and it will set the earner variable, this kernel, obviously, so that we will identify the exact cause why it is happening. Okay, so this earner variable is a global variable to a thread, but not to multi-threads. Okay, multi-thread cannot share the same earner variable. It is set per thread. So this is very important. Okay, so we have a header file for this as well, errno.h, which have all the errors that is mapped to this system cal error, that is -1 they are giving. Okay, so it is set by the system call and some library function when an error occurs. So function don't reset error to 0 on success. This is also very important. This helps in debugging your C program, because if you have some success API, some system call, it got success, it won't set to 0. It will be still the old failure in your program only. Okay, so it's very critical while reading this error variable after the system call. Okay, error is meaningful after a failure only, not on the success. We there is nothing for the success, but in case of a failure to a system call or some library function, we can use this earner variable. Okay, so I think you are clear with that. Let's go directly to the man page of Erno and see what all things there. So man 3, I'll take Erno, and when I open it, it will give you number of the last error. Erno will store the number of the last error, and the header file is erno.h. Okay, and this header file defines the integer variable erno, which is set by the system call and some library function in the event of an error that indicates what went wrong. Okay, so -1 for most of the system call, -1 or 0 is the return type. So if you are using system call like open, connect, like malloc, okay, so these are library function. Malloc is a library function. So still we are using Erno in that. So a function that success is allowed to change Erno. Okay, a function that succeed is allowed to change Erno. The value of Erno is never set to 0 to any system calls or library function. So this I mentioned. Okay, so this is also shown here. So we have some number associated with this Erno variable per thread. So what are the numbers? So if I quit here and I have Erno -l to list all the Errno variables and the string attached to it. So if you see here, there are a lot of errors. For example, eChild, if you are using parent child process and the child exit, no child process is there. So this is returned by the kernel. Okay, interrupted system calls, this error will be there. So we can check this error, no such file or directory, in case we are using the open system call. So uh, this macro is being returned to identify like this is the problem. Okay, so what is the advantage of using this Errno is we'll get the exact cause of the problem, not -1. For example, something has occurred. It has no meaning. If we want to debug in later stage, so it's very difficult to debug with -1. We have to identify the exact cause and we have to edit our code, compile our code, and recheck it. So if you use these Errno variables, that error is straight away shown there. Okay, so it's a lightweight uh, variable. We can use it. It helps to distinguish between a file not found and the permission denied to that file. So it can debug to that level as well. Okay, so let's take an example to see how the things work. Okay, so I'll open a simple example. So in that, what I will do, I'll open a file. So int fd is equal to open, and here I have a missing text file. Okay, and comma o underscore read only. Okay, and then if fd is equal to -1, then I'll printf. We have error comma percentage s. Then I have str error and Errno. Simple as that. And here I'll do program finished. Okay, so simple as that. And I'll start from here. I'll put program start. Okay, so this file is not there. Okay, so let's compile it and see what I will get. I will do gcc test dot error hyphen o err. Okay, I'll get some errors. So for that, I need to include the header files. I think I missed that. So first is errno.h. Okay, then I'm using string. So string.h should be there. And I have for open, I have fc and plu. Okay, now I am able to compile it. So if I do err, you see here program starts and it will show an error, no such file or directory. Error is very specific that we won't file this file itself. Okay. What happens here is when we open this file in read-only mode and we are checking the FD, it's returning as -1. And then we are, after just that, I will be printing out the string attached to this no error that is coming out. So this is a simple way how we can debug and send an error. Okay, so it is showing this one. Okay, so if we use, in spite of this, if I am using p error, okay, perror. So here, if I do file not found, okay, so if I do this and I compile it, you will see, you will get this no such file on directory similar to this and with the additional text. It means your p error is also using the Errno variable in the background. I need to check the value of the Errno. So what I will do, I'll do a printf here. Okay, and here what I will do, I'll take Errno is equal to percentage %d, and here I will just print the number associated with this. So if I compile it and do ERR, you will get the Errno value is 2. Okay, and Errno 2, if you get this, so this is the macro that is associated with this number. Okay, and this is a string attached to this for this error, not able to open this error. So few tips regarding this uses is, we need to use immediately after this error. For example, uh, in this system call, we are getting the error and we are checking the return type. And then after, I'm just getting this error or no. So if there is any other system call between this, okay, so then we should not use this no here with fd is equal to -1. It should be used immediately after this, because whatever system call is between this open and this fd, it might got failed. So if that system call got failed, your Errno variable will be changed, and here you will get a different result. Okay, so maybe that string might got changed, though both of the system calls fails, but you are checking it after both of the system calls, so it might be a problem. So this should not be done. Okay, so whatever system call we are using, immediately after that we need to print that Errno variable to decrease the risk. Okay, so better way to use this Errno variable, because this is global to this thread, it might be changed by the signals as well. So better if you take the saved Errno here is equal to Errno, okay, so that it won't be changed, and string error, and in spite of using this Errno, what I will be doing is I will be using saved Errno, saved Errno here. So let's take another example to make it more clear. So what I'm doing here is I am using a malloc function, and here what I will do, I'll take void star of ptr is equal to malloc one something big number. Okay, and if not ptr, then what I will do, I'll take a p error here, and I just print malloc field. Okay, so if I compile it, so I need lib here. So I'll put stdlib. Okay, so they are giving us some warning. So you see here cannot allocate memory. And if you print your Errno, printf Errno is equal to percentage %t, and here we have Errno, and again compile it. You see here your Errno is 12, and if we do Errno 12, you'll see here cannot allocate memory string is there. Okay, so this way we can put the debug statement in our code. So to quickly tell you how these Errno variables work in multi-threading, so what I will do, I'll take a new program, creating a thread. So let's write it first, then I will explain it. So let's explain this program now. So what I did was I have a thread. I launched a thread with a thread function. Okay. And I'm joining this thread and I am printing the Errno variable in the main thread, as well as I am taking this Errno variable as 42 here, and thread header I'm printing here with the return value as null. So this function will run in a thread, and this is the main thread which is giving you Errno variable what is there. So let's try it. So if I compile it with LP thread, and now if I run it, we'll see here program start and thread no variable is 42. It is printing there in the thread. But in the main thread, if you see here, the no variable is 0. So it's not been set. Okay. So similarly, if you go here and if I put no is equal to 6 here, and then I compile it again and do this, you see the main thread is not being changed while this thread is 42 only. So your Errno variable is set per thread. So that is the advantage of using the Errno thread. So this is very important thing. Just kept in mind. Okay. So if you have any query, just post me a comment. Okay. So this is all about this video. See you in the next video. Thanks.